will be limit n tends to infinity r upon n equal to 1 upon n. Okay, and at n tends to limit n tends to infinity equal to 0. Okay, and upper limit, what is the upper limit here? Upper limit will be at r is equal to n, limit n tends to infinity again, limit n tends to infinity r upon n, r upon n is equal to n upon n is equal to 1. Even limit we put here, limit n tends to infinity is equal to 1 here. Because n upon n is 1, then we apply the limit, doesn't matter. So limits are 0 to 1. Let me convert this into definite integral. So finally, we get here definite integral of this summation. This is converted to definite integral from 0 to 1. Now 1 upon n dx, this is 1 upon 1 plus x whole square into dx. This is 1 plus x here, r upon n is putting r upon n is equal to x, r upon n is x, that is, and 1 upon n, as I just told you that this is equal to dx, we replace that by dx. In this way, this is the conversion. Now, what is the integration of this function? It will be nothing but minus 1 upon 1 plus x. Why? Because if I take this in the numerator, it will be 1 plus x whole power minus 2. And integration will be 1 plus x minus 2 plus 1 upon minus 2 plus 1. So even if I take 1 plus x as u suppose, it is u is equal to minus 2. Okay, and then apply the limits then, or prove them u is equal to 1 plus x, so it will be minus 1 upon, because integration will be 1 plus x whole power minus 2 plus 1 upon minus 2 plus 1. That means minus 1 in the denominator. Negative sign will be there. And that 1 plus x whole power minus 1 is taken as 1 upon 1 plus x. I apply the limits here. This is minus 1 upon 2. First is at upper limit 1 plus 1 is minus 1 upon 2. Plus sign was minus 1 plus in between. It will be 0 here, so it will be plus 1. That means plus half. Minus half plus 1, that means plus half. If I take 2 LCM, it will be minus 1 plus 2. Minus 1 plus 2 means plus 1. 1 upon answer is 1 upon 2 here. This is answer of question number 7. Question 7 is solved now. Let me take the 8th question first. So now question number 8. What does it say? Let me check it. Now question number 8. Question number 8 says evaluate limit n tends to infinity. It is limit n tends to infinity. What is the series here? It is n upon n square, okay, plus n square upon, sorry, it is n upon, next is n square plus 1 square plus n upon n square plus 2 square plus and so on, and last is plus n upon, it is nothing but n square plus n plus 1 whole square, n plus 1 whole square. So what is the last term here? This is last term, n square plus n plus 1 whole square. Okay, now this is the question number 8. Let me check. N upon n square, okay, n upon n square whole square, n upon n square plus 2 square, okay, n upon n square plus n plus 1 whole square. Alright, so this is the series here we have obtained. Now here, okay, the limits are from, let me take Rx term solution here. So in solution of this, Rx term will be dr, or Rx term of this series. Rx term is equal to, we always write the limit n tends to infinity, okay, and this is sign of summation. What is r here? R is equal to 0 to n plus 1, because here n is r is n plus 1 and here it is 0. It is nothing but n upon n square plus r square. Okay, this is what we have obtained here. And here limits are 0 to n plus 1, because last term r in place of r we have n plus 1 here. That is the point. Okay, now let me take the limits or convert this into r upon n form. So this is n tends to infinity sigma sin r equal to 0 to n plus 1. Here, if n square, if I take form out of this bracket in the denominator, it will be 1 plus r upon n whole square. Okay, and this 1 n cancel out. The same form is there, which is nothing but limit n tends to infinity sigma sin r equal to 0 to n plus 1. It is 1 upon n into 1 plus r upon n, sorry, r upon n, I'm sorry, it is not whole square, but here it is whole square. Okay, now upper limit, lower limit, let me find out. So at, okay, upper limit, what the value is here, when n tends to, let me find out the limits here. Okay, so it will be, because in place of r we have n plus 1. Alright, so limits here, let me find out the limits. Lower limit, okay, will be what? R of, this is r upon n, I'm sorry. This is r upon n here. R upon n. Okay, so lower limit, again, at x equal at r is equal to 0 here, because we are starting from 0, or if we start from 0 to n plus 1, or r to n plus 1, we have no problem. Okay, so if it is 0, okay, then it is from 0 to, sorry, n minus 1 it will be done, but it is 1 to n plus 1. So this is what for 0 to, but there is one more term has been added up. This is 0 to n plus 1, no problem. Now this is r tends to, sorry, at r equal to 1, or r equal to 0, r upon n equal to 0, or at r is equal to 1, even then we have r upon n is equal to 1 upon n, which is distant, which is equal to 0, sorry, which is equal to 0. In both the cases it is 0. R upon n is 0. So lower limit is 0. Okay, so what is upper limit here? Let me find out. And upper limit, okay, and so upper limit is r upon n here again. So it will be 0 to 1. Okay, so at upper limit r upon n, at r is equal to n, okay, r equal to n is equal to 1. At r is equal to n is equal to 1. Upper limit is here again 1. Even if we substitute, when, because n tends to infinity, it is 1 upon n plus 1. If I substitute n plus 1, okay, instead of that n, okay, it is n upon n here, okay, but in the denominator then we have to substitute n plus n, n plus 1, sorry, because the terms are n plus 1 terms. So then it will be n plus 1 upon n plus n. And if I substitute here r upon n plus n, because terms are here n plus n times. Okay, so n plus n will be there. So in this case, 1 is there. So upper limit, lower limit, we have found out. So that we convert this whole into integral sign. Okay, into the integral. So what is the finally answer of this? This will be equal to, therefore, limit n tends to infinity, sigma sin r is equal to 0 to n plus 1. Okay, so this is 1 upon n into 1 plus r upon n whole square. It will be equal to 0 to 1. It is 1 upon 1 plus x square into dx. Now this is what? This is tan inverse x here. It is nothing but it is tan inverse x. because we know that 1 upon 1 plus x square is tan inverse x. Okay, now putting the limits here, it is tan inverse 1 minus tan inverse 0. Tan inverse 0 is 0. It is pi by 4 here. Tan inverse 1 is for pi by 4. So pi by 4 is the angle. Answer is pi by 4 here. The answer is pi by 4. For tan inverse 0 is 0. This is tan inverse 1, which is pi by 4. For tan pi by 4 is 1. Therefore, tan inverse 1 is equal to pi by 4. Pi by 4 is the answer in this case. Question number 8, we have done. Okay. Let's talk about next question. Now, ninth question says, what is ninth question say? Now, ninth question is also a series type. Okay, it is up to twice. Okay, no problem. Ninth question is evaluate limit n tends to infinity. It is okay. It is n upon n square plus 1 square. Alright, n square plus 1 square plus it is n upon this one n square plus 2 square. Okay, plus and so on. Last step is 1 upon twice n. Okay, here will 1 to n because last term will be n square plus or n upon n square plus n square. Because that means twice n square. N upon twice n square, that means 1 upon n, 1 upon twice n. Okay. Here, okay, let me write the find out the rth term. Solution here. The solution here. Rth term. So rth term of this series is equal to n upon. Let me first write it in the rth term here. This is r upon n square plus r square, where r is equal to 1 to n. So we can write it as limit. Okay, here limit n tends to infinity, or this is equal to n tends to infinity. Sigma sign r is equal to 1 to n. Okay, this is n upon n square plus r square. Okay, same thing here. 1 upon n square plus r square. Again, we have to take the common. It is limit n tends to infinity. Okay, this is sigma sign r is equal to 1 to n. I take n square common, it is 1 plus again r square upon n square. Sorry, n square, that means r upon n whole square. Okay, so this is equal to limit n tends to infinity. Sigma sign r is equal to 1 to n, 1 upon n into 1 plus r upon n whole square. A similar type of question, I think. But there it was 0 to n plus 1. Okay. Now let us take the same question here. Will sound let me take. Now what is the limits? Lower limit, upper limit, lower limit. Lower limit is at r is equal to 1 here. At r is equal to 1. So r upon n is equal to limit n tends to infinity. R upon n is equal to 1 upon n. Limit n tends to infinity is equal to 0. Because 1 upon n is equal to 0. And 1 upon n, n tends to when n tends to infinity is equal to 0. In lower limit. Upper limit. Upper limit is equal to limit n tends to infinity. It is r upon n equal to limit n tends to infinity. It is n upon n when r is equal to n is equal to 1. limits are these. Okay, so let me convert this into a definite integral family. Therefore, this whole is equal to 0 to 1 upon 1 plus x square here into dx. So r upon n we will put as x, which is x square, 0 to 1. Again, it is tan inverse x, 0 to 1. This answer is also pi by 4. It's minus 0. Pi by 4 is answer. I think the same answer is coming out. Okay, no problem. The two series are same, but obviously by starting is different. Okay, in the first one it was n square plus r square was 0 there. There was also 0 to 1. Same limits were there. Okay, now let me take 10th question. With the 10th question here. No question number 10th. What does it say? Let me talk about question number 10 now. No, question number 10. It says evaluate limit n tends to infinity. Limit n tends to infinity. It is 1 square upon 1 cube plus n cube. It is n cube here. Plus 2 cube upon, it is 2 square. I'm sorry, it is 2 square upon 2 cube. That is, okay, 2 cube plus n cube plus and so on. This is the tens. 1 square upon 1 cube plus, in the denominator we have cubes. Okay, 2 cube, n cube plus another term is n cube, n square, sorry, upon n cube plus n cube. Okay. So another rth term, first we find out solution. Let me find out the solution of this. Solution of this, we start from finding out first rth term. After that, we find out that lower limit, upper limit, and then convert it into definite integral 0 to 1 limits and fx dx. In that form, we convert that, and x is r upon n, 1 upon n is dx, and sigma sign, summation of sign, and the limits is converted into the sign of integration. That is how we convert it. Let me read rth term. The rth term of this equation, that means dr, is given by r square upon r square, sorry, r cube plus n cube. It is here. Now let me put the limits. Limit n tends to infinity. Sigma sign r is equal to here 1 to n. R is equal to 1 to n because this is 1 here. R is equal to 1 to n. Let me write clearly. This is limit n tends to infinity. Sign of summation r is equal to 1 to n. R square upon, it is r cube plus n cube. Okay. Now let me take n cube out. What it will be? Let me change it into, so limit n tends to infinity. It is the sign of summation r is equal to 1 to n. If I take r square upon n cube out in the denominator, it will be 1 plus r upon n whole cube. Okay, and the denominator can be written as limit n tends to infinity, sign of summation r is equal to 1 to n. It is r upon n whole square. I have taken over n square, this is n cube here. 1 n square to denominator, that is r upon n whole square, divided by n into, within bracket, I'm sorry, within the square bracket, it is 1 plus r upon n whole cube. This is the question. Okay, so now this can be converted as r upon n, this whole is converted into form r upon n, 1 upon n, etc. Now it can be the same limits are. So limit, let me find out. What are the limits here? Now limits, first is lower limit. Same lower limit, 0 it will be. Okay, at r is equal to 1, it is 1. Okay, r upon n, limit n tends to infinity, r upon n will be 1 upon n, limit n tends to infinity, it will be 0. Okay, and upper limit is 1. What is the upper limit here? Upper limit at limit n tends to infinity, or 1 upon n tends to 0, will be right. No problem at all. R upon n, r upon n is equal to n upon n is equal to 1. Limit is here, limit n tends to infinity, no problem. For 1, 0 to 1 limits, we can convert this into definite integral. So what is this? Therefore, this whole is equal to 0 to 1 limits. Okay, and this is x square r upon n, the numerator is r upon n whole square, that means x square upon 1 plus x cube, 1 plus x cube into dx. Now this is the definite integral. Now we can take denominator, putting denominator, okay, putting 1 plus x cube, that we take equal to t, 1 plus x cube equal to t. Therefore, 3x square dx equal to dt. Differentiating it with respect to t, then differentiating it with respect to t, we get 3x square upon, let me write here, upon dt, dx upon dt equal to 1, or 3x square dx equal to dt, or x square dx equal to dt by 3. What are the limits here? By convert limit, at x equal to here, at x equal to 1, p equal to 2, because 1 q is 1. So at x equal to 1, t is equal to 2, and at x equal to 0, at x equal to 0, t equal to 1 here, t equal to 1. Because when we substitute here x equal to 0, t equal to 1, and x equal to 1, 1 q is 1, 1 plus 1 is 2. Upper limit is t 2, and lower limit is 1. Here limits 1 to 2. Okay, it is dt by 3, that will come from 3 out, we take, divided by t from d, which is nothing but log t. We log t here. Limits are 1 to 1.3 is also there, 1 to 2. So it will be 1.3 log 2 minus log 1 is 0, minus 0 here. Only 1.3 log 2 is the answer. Here base is e, we cannot write e, we do not write e mostly, it is omitted. So answer is 1.3 log 2, simple. So log of 2 in the base e, mostly omit. It is 1.3 log 2. Answer. Question number 10 is solved finally. This is question number 10 here. Let me take next question. 11th question. What does 11th question say? Now question number 11. Let us talk about question number 11 is of what kind? Let me clean it. Okay, question number 11 now. What does it say? Okay. Question number 11. This is 9th one. Now 10th is this, 11th is this. Rebel with limit this. Okay. Let me check it. So question number 11 here. It is limit n tends to infinity. Okay. Here Rx term has been given. So limit entering to input is sign of summation, which is r equal to 0 to n minus 1 equal to n minus 1. Okay, 1 upon, this is under root n square minus r square. This is Rx term given here. So what is sum of the series? Okay, so we find out. So here it can be taken as, okay, out of this n can be taken out, that will be 1 upon, and here, okay, this is limit n tends to infinity, sigma sin r equal to 0 to n minus 1. It is 1 upon n out of the square root. If I take n square out, it will come out as n. It will be 1 minus r upon n whole square inside the square root. This is the value. So it is converted 1 upon n, r upon n, etc. Now what is the okay, limits here same. So limits, let me find out. Lower limit first. Again, lower limit at r is equal to 0. Okay, so r upon n equal to 0 here, or limit n tends to infinity even, then it is 0. And upper limit, what is the upper limit here? Upper limit at r is equal to n. Okay, at r equal to n mostly we take, or we could take 1 to n. If it is 1 here, let me take here at r equal to. We can take either 1 to n or 0 to n minus 1, doesn't matter. It can be written as 1 to n minus 1 also. Both are same, as we have already clarified this. So either we take 1 to n or 0 to n minus 1, same thing is obtained. No, that's not a problem. At r is equal to n, r upon n, limit n tends to infinity will be equal to n upon n, limit n tends to infinity, sorry, n tends to infinity equal to 1, because n upon n is 1. That is the question here. Now let me convert this into definite integral. Therefore limits are 0 to 1. This whole will be converted into 0 to 1 limits 1 upon under root 1 minus s square into dx. Now what is this? It is sine inverse x, nothing else. Because we know that 1 upon under root 1 minus x square is sine inverse x. Limits 0 to 1. Put the limits here with sine inverse 1, okay, minus sine inverse 0. Sine inverse 1 is 5 by 2. 0 answer is 5 by 2. So question number 11 we have done. This answer is 5 by 2. Okay, question number 11. Now let me talk about 12th question. What does 12th question say? Let me check it. Now question number 12 is again another term, r term is given here. Question number 12, evaluate limit n tends to infinity. Okay, n tends to infinity, sigma sin r is equal to 1 to n minus 1. Again, we take r equal to 1 to n minus 1. Not a problem. R equal to 1 to n minus 1. Under root, it is n square minus r square divided by n square. Okay. So it can be written as limit n tends to infinity, sigma sin r is equal to 1 to n minus 1. Okay, if I take n common out of this bracket, it will be n out, n square out. Sorry, n square if I take out of the square root, it will come out as n, will be 1 minus r upon n whole square divided by n square, which is 1 upon n. Finally, we can convert this into definite integral. What are the limits here? Limits, let me find out now. Limit at lower limit first. First is lower limit at r is equal to 1. So limit n tends to infinity. Okay, n tends to infinity. R upon n, sorry, R upon n is equal to 1 upon n, limit n tends to infinity equal to 0. So lower limit is 0. Upper limit, same thing. What is the upper limit here? At r is equal to 1, r upon n, sorry, r is equal to n, it is equal to, because we add any number of terms doesn't matter, because it is definite integral when n tends to infinity, and n is definite number, or sorry, indefinite number, and finite numbers are there, a finite range of numbers between a to b, limit 0 to 1, the number of terms which are finite, and we can write other limits n or n1, doesn't matter. Okay, it doesn't change the same answer. This is n upon n, this is 1 here. So upper limit 1, lower limit 0. Same thing at limit, this is 0, n tends to infinity. Okay, so limits are again 0 to 1. Let me convert this now into definite integral. Finally, what do we get? So we get it at 0 to 1. It is under root 1 minus x square into dx. What is the integration of this? This we have dealt in previously. So what is the answer of this? This is 1.2 x under root 1 minus x square. Limits 0 to, let me write the limits in the end. Okay, and this is plus sign here, 1.2 x, sorry, it is sine inverse x. Sine inverse x here. Okay, limits now 0 to 1. Now if I take 1.2 common throughout, or this is in both the cases, if I write here 1, this is 1 minus and 0. Okay, this first term is 0 in both the cases. At 0, it is 0 into something 0. First term is in both limits 0. Second term, let me find out. It will be 1.2 sine inverse 1 minus 1.2 sine inverse 0. It is 0. This is 1.2 sine inverse 1 is pi by 2. It is pi by 4 only, because sine inverse 0 is equal to 0. So this is equal to 1.2 sine inverse 1 minus 0. Okay, so sine inverse 1 is pi by 2. 1.2 into pi by 2, that is equal to pi by 4. So this is the answer here. So question number